Welcome to Mr. Layman's Knowledge Explosion. The purpose of today's video lesson is to use Euclid's idea of points to discuss distances, positions, and lengths of objects. By the end of this lesson, you should be able to find the distance between 2 points if you are given their initial coordinates. Before we can begin calculating distances, we need to understand the importance of postulates, also called axioms. A postulate is a statement that is not proven to be true, but is so strongly supported by evidence, and usually very simple and almost obvious, that it is accepted as a fact for purposes of discussion. Recall that Euclid declared he could build all logical arguments from his undefined terms point, line, and plane. He also used postulates, such as the Ruler Postulate, which we will use to help explain how to find the distance between 2 points. Here's an important note. All statements must have a reason to justify them, even if that statement seems excruciatingly obvious. The Ruler Postulate is a great example of a simple idea that we can use to justify future statements. The Ruler Postulate states the following. Points on a line can be matched on the number line to real numbers so that the distance is equal to the absolute value of the difference between the coordinates. Now, I don't know about you, but for something that is supposed to be simple and obvious as a postulate, that may sound a little confusing at first. Unfortunately, that can happen sometimes in geometry when you put ideas into words, but I assure you, all those words are necessary. Let's think of it this way. Imagine you went fishing and the lake regulations say you can only keep fish longer than 10 inches. Unfortunately, your last teacher broke your ruler and you only have this remaining piece. No worries, the Ruler Postulate says we can match the starting and ending points of the fish on the number line, and the distance is simply the difference between those 2 points, in this case, 4 inches. So why make it confusing with that absolute value part? Well, that part allows us to start at either point and still do the subtraction. 10 minus 6 is a distance of 4. But 6 minus 10 is negative 4, which doesn't make sense until we take the absolute value, which then makes that distance a positive 4. But what if you catch a fish that is over the length of your ruler? Another useful postulate we can use is called the segment addition postulate. The segment addition postulate states that if point B is between points A and C, then the length of AB plus the length of BC is equal to the length of the entire segment AC. For our fish, we can mark a point A and C at the start and end of the fish. Then we can mark a point B somewhere between points A and C. We will measure the lengths of AB, measure the length of BC, and add them together to find that this fish is the acceptable 10 inches, and we can keep it. Now is a good time to remind you of the differences in notation. Using only 2 letters, A and C, can mean different things. Remember, a line with 2 arrows over the top refers to line AC. A bar with no arrows means line segment AC, and a line with 1 arrow means ray AC. If you ever see 2 points together with no markings above them, that is referring to the length of the line segment AC, or simply the distance from point A to C. I know it's a lot to remember, but the devil is in the details here. So what do we do if the 2 points we are trying to find the distance between are not on a nice vertical or horizontal line for me to use my ruler, like the fish? By placing a grid over points A and B and locating their coordinates, we can use the Ruler Postulate to find the horizontal and vertical distances that would connect the 2 points. Let's label that point of intersection point C. In this example, we can see AC is equal to 12 units and BC is equal to 5 units. Connecting the points creates a right triangle, so borrowing an idea from another Greek mathematician, Pythagoras, we can use the Pythagorean theorem to calculate the length between our 2 points. The Pythagorean theorem states that a squared plus b squared equals c squared, where a and b are the legs of the triangle and c is the hypotenuse, or in our case, the distance we wish to know. For our example, 5 squared plus 12 squared equals 169. So c squared is equal to 169, which means c is 13. And that is the distance between points A and B, which we would write like this. As most of you know, counting is not one of the things I do best. So rather than count the horizontal and vertical units, I use a slightly different strategy. Many times I do not have graph paper with me, so I will make a rough sketch and write the coordinates next to each point I am working with. Then I will find the horizontal distance by subtracting the x-coordinates, and I find the vertical distance by subtracting the y-coordinates. Remember, distances cannot be negative, so it does not matter which x or y coordinate you start with, or if some of the coordinates are negative as long as you remember to take the absolute value of the subtraction. In this example, I will start with the horizontal length of AC, or the x-coordinates. Negative 4 minus 3 is equal to negative 7, but the absolute value of negative 7 is 7, so that is my horizontal distance of AC. To find the vertical length of BC, I will subtract the y-coordinates. 6 minus 5 is 1, so the vertical distance is 1. I will now use these lengths in the Pythagorean theorem to calculate the distance from point A to point B. 1 squared plus 7 squared is 50, which is equal to c squared. That means I must square root 50 to find that the exact distance from point A to point B is 5 root 2. If the directions state that you should leave your answers in exact form, then do not use a rounded decimal or an approximation. For a refresher on simplifying square roots, please refer to the Simplifying Square Roots video on my webpage. Thanks for watching this episode of Mr. Lehman's Knowledge Explosion. For more practice on finding the distance between 2 points, go to page 54 in your online textbook. Thanks, and good luck.